Welcome to S&D College of Engineering, Yeola. In last video, we discussed half-range Fourier series. The half-range Fourier series is of two types. The first one is half-range cosine series, and second one is half-range sine series. First, we will see half-range cosine series in the interval 0 to pi. So here we just revise the formulas to find the half-range cosine series for the interval 0 to pi. So here the formula, the half-range Fourier series is represented by f of x is equal to a0 by 2 plus summation n runs from 1 to infinity an into cos nx. Such this series represent the half-range cosine series for the interval 0 to pi. So in which half-range cosine series, the Fourier coefficient a0 and an are present. So to determine the value of a0 and an, the formulas are given. So formula to find the a0 is equal to 2 upon pi integral 0 to pi f of x dx. To find the Fourier coefficient an, the formula is n is equal to 2 upon pi integral 0 to pi f of x cos nx dx. In the half-range cosine series, the value of bn is always 0. So in this way we find the half-range Fourier cosine series for the interval 0 to pi. And if you change the interval from 0 to pi to 0 to L, the half-range cosine series is a function f of x is equal to a0 by 2 plus summation n runs from 1 to infinity an cos n pi x upon L. The Fourier coefficient a0 and an can be determined by using the formula a0 is equal to 2 upon L integral 0 to L f of x dx, and an, which is determined by using the formula 2 upon L integral 0 to L f of x cos n pi x upon L dx. We know that in the cosine series the value of bn is always 0. Next half-range series is half-range sine series, which is to be defined in the interval 0 to pi. So the half-range sine series for the function f of x, which is represented by f of x is equal to summation n runs from 1 to infinity bn into sin nx, in which the Fourier coefficient bn, which can be determined by using the formula bn is equal to 2 upon pi integral 0 to pi f of x sin nx dx. The value of a0 and an are always 0 in half-range sine series. Next, the half-range sine series for the interval 0 to L. The half-range sine series for the interval 0 to L, which is represented by f of x is equal to summation n runs from 1 to infinity bn into sin n pi x upon L. The Fourier coefficient bn can be determined by using the formula bn is equal to 2 upon L integral 0 to L f of x sin n pi x upon L dx, and the Fourier coefficient a0 and an are always 0. So these are the formulas to determine the half range series, cosine series as well as the sine series. Now we see some example on the half range Fourier cosine series and sine series for the different intervals 0 to pi and 0 to L. So the first example is find half range cosine series for f of x is equal to e raised to minus x. Here the interval is 0 to pi. So to find the solution of half range cosine series for function f of x, first we write the given function f of x is equal to e raised to minus x. Here the interval is 0 to pi. And we know that in half range cosine series, the value of Fourier coefficient Pn, which is always 0. Now, the remaining Fourier coefficient a0 and an can be determined. So, we know the formula to find the a0. a0 is equal to 2 upon pi integral 0 to pi f of x dx. We substitute the value of the function as e raised to minus x, which is given. So 2 by pi integral 0 to pi e raised to minus x dx. Now we determine the integral. So the integration of e raised to minus x is minus e raised to minus x, and the limits for the function is 0 to pi. Next, by applying the limits to the function, so we get minus 2 upon pi. From here minus sign we take outside, so minus 2 upon pi, by applying the limit e raised to minus pi minus e raised to minus 0. We know that e raised to minus 0 is 1 and e raised to minus pi we keep as it is. So we get the value by absorbing this minus sign into the bracket. So we get the value of a0 as a0 is equal to 2 by pi in bracket 1 minus e raised to minus pi. Now we find the next Fourier coefficient an. So to determine the value of an, the formula is an is equal to 2 by pi integral 0 to pi f of x cos nx dx. We substitute the value of the function f of x as a e raised to minus x, which is to be given. So n is equal to 2 by pi integral 0 to pi e raised to minus x cos nx dx. By using the formula e raised to minus ax cos bx dx, we determine this integral. So the formula, we know the formula, integral e raised to minus ax cos bx dx is equal to e raised to minus ax upon a square plus b square in bracket minus a into cos bx plus b into sin bx. So the integral is integration of the function e raised to minus x cos nx dx is 2 by pi in bracket e raised to minus x 1 upon 1 plus n square in bracket minus cos nx plus n sin nx. By comparing the integral these two, we get the value of a as a minus 1 and the value of p as a n. So we get the integration. Next, by applying the limits, so the upper limit is pi and lower limit is 0. So the integration becomes e raised to minus pi 1 plus n square in bracket minus cos n pi plus n into sin n pi minus e raised to minus 0 1 plus n square in bracket minus cos n0 plus n into sin n0. So in next step, n is equal to 2 by pi e raised to minus pi divided by 1 plus n square. The value of cos n pi is minus 1 raised to n, minus sign we keep as it is. The value of sin n pi is 0, minus e raised to 0 is 1, 1 plus n square. Sin 0 is 1, so here is minus 1 is remaining and sin 0 is 0. So in next step we get 2 by pi e raised in bracket e raised to minus pi upon 1 plus n square in bracket minus 1 raised to n in second bracket minus 1 upon 1 plus n square. So next we get here minus sign we take outside, so here the plus sign is there, plus sign. Next by here the denominator is same, by base is same, so we take the addition of the numerator, so we get the terms 2 by pi 2 upon pi into 1 plus n square into 1 minus 1 raised to n e raised to minus pi. So we get the value of a0 as well as n. So we know that the Fourier cosine series, half range cosine series, which is a of x is equal to a0 by 2 plus summation n runs from 1 to infinity n cos nx. So substitute the value of a0 and an. So the f of x is equal to 2 by pi in bracket 1 minus e raised to minus pi upon 2 summation n runs from 1 to infinity 2 by pi into 1 plus n square 1 minus 1 raised to n e raised to minus pi into cos nx. So f of x is equal to 1 minus e raised to minus pi upon pi plus 2 upon pi summation n runs from 1 to infinity 1 upon 1 plus n square 1 minus 1 raised to n e raised to minus pi cos nx, which is the required Fourier cosine series for the function f of x is equal to e raised to minus x. Now the next example. The next example is find half range cosine series for f of x is equal to x minus 1 bracket square. So interval is 0 to 1. So to find the Fourier's half range cosine series, we write the given function. So here the given function is f of x is equal to x minus 1 bracket square and the interval is 0 to 1. In half range cosine series, the value of bn is always 0. By comparing the interval with the general form 0 to L is equal to the 0 1, so the value of L we get 1. So therefore the formula to determine the value of a0 Fourier coefficient, which is 2 by L integral 0 to L f of x dx. By substituting the value of L, a0 is equal to 2 by 1 integral 0 to 1 x minus 1 bracket square dx. The integration of x minus 1 bracket square, which is x minus 1 raised to the power 3 divided by 3. The limits 0 to 1. Here we apply the limits. By applying the limit, we get the value of a0 as a 2 by 3. Similarly, we find Fourier coefficient an. So we know the formula to determine the Fourier coefficient an, which is equal to 2 by L integral 0 to L f of x cos n pi x dx. The value here we substitute the function f of x and the value of L. So an is equal to 2 by 1 integral 0 to 1 x minus 1 bracket square into cos n pi x upon 1 dx. So here the integral which becomes 2 times integral 0 to 1 x minus 1 bracket square cos n pi x dx. By applying the formula integral u into v is equal to u into integration of v minus derivative of u is u dash into v2. v2 is nothing but integration of v1 plus u double dash into v3. v3 is integration of v2 and so on. The formula will be continued. So the formula is applicable only for the one of the function u, either u or v is the polynomial function. So by applying the formula we get the integration of the integral x minus 1 bracket square into cos n pi x. So integration we get an is equal to 2 in bracket x minus 1 bracket square, we keep u as it is, the integration of v sin n pi x upon n pi minus we take the derivative of the polynomial 2 into x minus 1, the integration of this v1 which is minus cos n pi x upon n square pi square plus 2, that is derivative of the polynomial, into minus sin n pi x upon n cube pi. By applying the limits and simplification we get the value of an as 4 upon n square pi square. We substitute both the value in the Fourier series expansion half range Fourier cosine series, which is represented by f of x is equal to a0 by 2 plus summation n runs from 1 to infinity an cos n pi x upon n. So the value of a0 and an we substitute, so we get the Fourier series f of x is equal to 1 by 3 plus 4 by pi square summation n runs from 1 to infinity 1 upon n square cos n pi x. Thank you.